So this is a worked example on how to graph a polynomial function just by having the factored form. So we're just going to be using zeros, multiplicities, and end behaviors to graph this function. So in the worksheet, you can see that I list out the 3 big clues you're going to try to figure out, and then we're going to use this information to graph the function. So let's go through each of these things and figure out what we will be filling in. So the first thing we want to find are the zeros, and these zeros can be found just by setting each individual term equal to 0. So my first term, if I set x plus 1 equal to 0, well, I can see that x equals -1. If I set x plus 2, now this is squared. However, if I immediately square root both sides, the square root of 0 just stays as 0, so we can actually just solve the inside portion. So x plus 2 equal to 0, I get x equals -2. And if x plus 3 is equal to 0, well, I get x is equal to -3. Alright, so these are our zeros, these 3 values right here. But we also want to write down the multiplicity. And so the multiplicity of each 0 is going to be equal to the power at which the term was raised. So this x equals -1 term, it originated from this bracket, or this term right here, and it's raised to sort of an invisible power of 1. So the multiplicity in this case is m equals 1. And the same goes for x equals -3, actually. M equals 1 as well. And in the one interesting case we have is that term, as I mentioned earlier, x plus 2, that is squared, and that's raised to a power of 2. And so the multiplicity in this case will be m equals 2. Okay, and the last thing we want to find out is end behavior. Now, end behavior you might need to work a little more to sort of figure out. And reason being that in these specific questions, we're not provided the original polynomial. We're only provided its factored form. And to figure out end behavior, we want to look at the leading monomial term of a full unfactored polynomial. So we're not going to go through and multiply this whole thing out. That's going to be a lot of work. But we want to imagine what might happen if we did, right? So we have 3 instances of x showing up, and one of them happens to be squared. So if I go ahead and multiply out this whole equation, I'm going to be multiplying, when I think about the largest thing I can multiply out, I'll be multiplying an x, another x, and an x squared. And if I have x times x times x squared occurring at some point, that largest possible x value will be an x to the 4th term. And I can also see that I don't have any random negative coefficients lying around that would turn this into a negative x to the 4th. None of those exist. And so I can understand that when I expand this polynomial out, the largest term that I could get is an x to the 4th term. And so what that implies for end behavior is that implies a shape like this on the graph, a U shape. More concretely, I could write that as x approaches -infinity, the function approaches infinity, and as x approaches +infinity, the function approaches +infinity. And so my whole polynomial function is actually going to mirror this. So now we can actually go ahead and draw a graph. So let me put down some axes. I'm going to tend it towards the negative side just because we have more negative values than positive values here. So let me pull this over. Okay. And so what I can do first is I can mark down each of my zeros. So we have -3, -2, -1. All of these are going to get a 0. What I then like to do, and I will erase this later, is I like to draw arrows sort of pointing in the direction of my end behavior just so I know where to sort of start and finish my line when I'm graphing it. So it's going to have end behavior that looks like this. And again, we'll erase these arrows later. And then I'm going to start drawing my line, but we want to be careful when we get to the point, or to the 0, x equals -2, because that has a multiplicity of 2, and so we're going to have a rebound off of the x-axis. And I'm going to start and end according to my end behavior. So watch what I'm going to do here. We'll start up here, because that's where our function is going to come in. It's going to strike through the point at -3. It's going to go to -2, but it's going to rebound off of the graph. It's going to continue to -1, strike through because of multiplicity 1, and then end at positive infinity like this. And so this graph here, it might not... I just dropped my pencil. This graph here might not be super accurate to what a computer would show. I mean, on my monitor here, I mean, you can't see it, but I have Desmos pulled up. Did I do a good job? Not really. This part right here should be a little flatter. I kind of made it too sharp. But that's not the point here. The point is that we're demonstrating our ability to find clues from a function, find the zeros, find the multiplicity, find the end behavior, and draw a pretty good picture. Not perfect, but a pretty good picture. And so that's sort of the complete process of looking at a factored polynomial and producing a sketch of a graph.